Okay, so we're going to use those divisibility rules in order to find the prime factorization for each of these numbers here. So when I'm doing this, I actually want to find the largest number possible. So I'm going to kind of go through all of the rules quickly and then use the largest one. So my first number I would test would be 2 still. The last number is a 6, so I know it's divisible by 2. I'm just going to make a little list over here to the side. 3, I would have to add the digits. So 6 and 6 is 12, and another 6 is 18. So it is divisible by 3. And when I was checking that, I could also tell it's divisible by 9 because 18 is divisible by 9 as well. The last 2 digits make the number 16, so it is divisible by 4. The last number is a 6, so it is not divisible by 5 or 10. And those are all the ones I needed to test. So the first one I want to use is the largest of these. So that would be the number 9. So I'm going to take 5616 and divide it by 9. So let's see, 9 will go into 56 6 times. That's 54. Subtract. That gives me a 2. Bring down the 1. 9 will go into 21 twice. That's 18. Subtract. Gives me 3, and then bring down the 6. So 9 will go into 36 4 times. So far, I can rewrite 5,616 is 9 times 624. Oops. All right, so now I'm looking at 9 and 624. 9 I know is 3 times 3, so I could break that down, but I'm just going to put that off to the side for a minute. I'm going to work now with 624. So for 624, again, I want to find the largest factor that I can, because the larger the number I can come up with, the quicker I'm going to get down to the prime factorization. So I know it's divisible by 2. The last 2 digits are 24, so it's definitely divisible by 4. I'm going to see if it's divisible by 9 by adding the digits. 6 and 2 is 8 plus 4 is 12. So it's not divisible by 9, but it is divisible by 3. So the largest number I came up with, well, I came up with 2 and 3, so that means it's divisible by 6. I guess I skipped over that one on the previous time. Okay, so anyhow, dividing by 6 gives me a 0. So bring down the 2. 6 won't go into 2, so that's a 0. Bring down the 4. 6 will go into 24. That didn't show up. 104 times. So now I can rewrite it as 9 times 6 times 104. And again, 6 is easy to break down, so I'm going to focus on 104 next. Okay, so 104. Let's see, divisibility rules again. The last 2 digits make the number 4, so I know for sure it's divisible by 4. The sum of the digits is 5, so it's not divisible by 3 or 9. And the last digit is not a 0, so 4 is my only option. So 4 will go into 104. Let's see, 4 will go into 10 twice. And then 4 will go into 24 6 times. Okay, so now I can rewrite this again. 9 times 6 times 4 times 26. And now I'm down to reasonable numbers where I can break these down individually. So 9 is 3 times 3. And 6 is 3 times 2. And 4 is 2 times 2. And then 26 is divisible by 2. It's 2 times 13. So typically for prime factorization, I want to write the factors in order from least to greatest. So I'm just going to rearrange them and put all of the 2's together. So technically, I don't really have to write them out long ways because we know about exponents. So since there are 4 2's here, I could say that that's the same as 2 to the 4th power. And then for the 3's, there were 3 3's, so this would be 3 to the 3rd power. And then the only thing left is a 13. Okay, now you're going to try this one here. So find the prime factorization of 585. It should look something similar to this, just prime numbers with powers.